Hi everyone, welcome. I'm VP of Engineering at Embrace, and I'm here today to talk about how to improve your mobile app performance. So without further ado, let's take a look at the agenda. Today we'll learn a little bit about why mobile app is business critical and the performance becomes even more business critical. We'll get a quick intro into Embrace and our core differentiator, which is session-based monitoring. We'll delve into three important performance issues which are basically slow startup times, freezes and ANRs, and device side or client side networking issues. So let's take a look. If you see every day and every year, the amount of apps we download, the amount of money we spend in them, and the amount of time we spend in them continues to increase. So if your business isn't already mobile, it's only a matter of time. So what exactly is the problem? Well, as you know, the competition is getting tougher and it's even more difficult to differentiate on the product alone. So companies are increasingly competing on the performance. User expectations are even higher. Users are not going to wait and sit and wait for the app to come out of the freezes or slow performance or even from the client side networking issues. It's not enough to offer your product or a service through an app. You have to make it as simple as possible and get users to experience value as quickly as possible. Well, you might be wondering, so hey, what exactly is the real problem? Well, if you look at it, I've been in mobile app development for over 2 decades, and I've seen traditional monitoring approaches which are very constrained towards logging. The teams either rely on limited solutions like crash reporters and error monitoring solutions. And all the traditional monitoring solutions, what they have done is they've turned around the solution which was working for the server side, but doesn't really work for the mobile. For example, they look at one tool for networking data, another for logs, another for crashes, and another for user journeys. All this result in mobile teams guessing at the root cause instead of having a reliable path forward. Mobile team needs a reliable way to deliver superior mobile app performance. Let's take a quick look at what Embrace do and let's get a quick intro on the Embrace. Embrace is a unified mobile monitoring and observability solution. That means we are 100% focused on the mobile. Our core differentiator from other monitoring solutions is that we provide mobile observability through capturing 100% of complete user sessions, and we directly correlate it with all the metrics, logs, traces to the individual's affected sessions. What that means is we are able to correlate all the data and provide the impact of the issues on your users, thereby providing an impact on your business growth and the revenue. So instead of guessing or continually building up the visibility pieces by adding logs, you get complete visibility into every user's experience. This makes it easy to solve any issue by reviewing the full details from the user's perspective. I'll spend a little bit time over here on the session-based monitoring, as you can see in this visualization. Unlike transaction-based monitoring, where the single unit you are measuring is an event or a series of grouped events accomplishing a single task, at Embrace, we view the user experience as the core data point. That means whenever a user foregrounds the app, you have a time-based data set of every view and screen, tap and button presses, network calls, logs, device states like CPU and memory and frozen screens and more. From the moment a user launches the app until they background it is one of the session. The other blocks, what you see over here, we also stitch the nearby sessions together. So if a user answers a phone call in the middle of a key purchase funnel, you can connect those sessions into one unified overview. You can also see the chronological order in which user has interacted with the app, and you can actually replay those sessions in your environment to be able to reproduce those issues and get to the root cause analysis for that issue quickly. In summary, traditional monitoring focuses on capturing specific events, while Embrace focuses on capturing the entire user experience and the impact of the user experience caused by those issues. So let's look at our first example, which is the slow startup time. When I would build mobile apps, I was always getting frustrated with each time I would have a release, and there's so much we add in during the initialization phase. There will be a time when customers would report the app takes a little more longer than usual during the startup. I wanted a proactive or a way to discover, if the startup times are going down or up. So what causes the startup times to bloat up? There could be a network call which is blocking many critical parts. There could be too much of work going on which is creating a congestion. There could be a third-party SDKs which are causing the high initialization time. Typically, as an engineers, we apply caching during the initialization. There could be a poor caching, or maybe there's an app is downloading unnecessary assets. Sometimes, the client-side apps, they are interacting with the backend services, and it takes longer for them to respond the network calls. If you don't have a dedicated solution for mobile network monitoring, you are relying on your backend to reliably tell you about your app performance on the devices in your user's hands, which it cannot do. What you are used to is tracking the startup time at a bird's eye view. Well, if you look at this screenshot over here, what probably you are used to is monitoring your startup time with something like this. You're tracking the percentage of how often your startup fails. How long does it take, whether it's a medium startup time or something like P95 threshold. But what's missing here? If your startup duration increases, is that a cause for concern? If the number of startup failures increases, do you need to jump in and investigate? You don't know. Basically what you're looking at is monitoring the startup time in a very generic way. However, what you need are the user impact and the technical details behind why the slow startup is happening. You need to know how users react to the change in your app startup. For example, we're looking at the percentage of stalled app startups here, which is very high at almost 75%. This metric represents a percentage of sessions that a user waited for a startup to complete, but it unfortunately failed. May I repeat? This is the time when user waited for a startup to complete and it unfortunately failed, which implies that users were patient and willing to tolerate a slow startup, but that a technical failure prevented them from using the mobile app. And I said user expectations are increasing. How are you measuring this today? And if you wanted to investigate such an issue and see what was causing these slow startups, what would you do? Here we dwell into the full chronological order of how user session was played. So as you can see over here, you can see when the startup happened, what were different connectivities, what was the different views user went to, and the tons of different network calls which were being made. We can dive directly into complete technical details of what happened. We can see everything. We can see third-party SDKs could be blocking the main thread. You could be loading too many SDKs. You might have connection errors due to DNS issues or loss of connectivity client side. The important thing is you don't have to guess. You see exactly what happened in the production. This is what mobile observability is all about. Going from user behavior signals, such as waiting for stalled startups or worse, abandoning slow startups, to understand the technical causes. So here are some key tips for solving the slow startups. Track your startup duration, don't stop that. And failures which spot the regressions. Always audit your SDKs and keep only the ones that are necessary. What I mean is third-party SDKs or any libs what you're using. Make sure to review your users' sessions to see which one is slow or failing as a cause, because those are the ones which can bloat up the startup time. Monitor where users abandon your startup to spot optimization opportunities. Let's get into the second example, which is freezes and ANRs. ANRs are application not responding or frozen experience that leave user frustrated and cost your business revenue. Imagine yourself using an app and you're trying to add something to the cart, or if you're playing the games and then an ad pops up and it just sticks around and you're trying to close it and it doesn't close. So let's investigate more about ANRs and what data is needed to effectively take action. Before we delve into it, what causes ANRs? ANRs in general are basically when the main thread of an application is blocked, which is a common issue, which includes, so there could be a network call which is blocking the main thread. Typically a very heavy UI rendering layout happening and expensive data transformation happening, which is blocking the main thread. This is something very common what we have seen in the gaming companies and the gaming apps. There could be a misbehaving third-party SDK and they are trying to get access or fight for the resources so that they can show their ads. And there could be a background services which could be blocking the main thread. These are several different causes which can cause freezes or ANRs within your app. What you're used to is you're used to treating the ANRs the same way as crashes when they are fundamentally different. By that, I mean the only data they provide developers is stack trace taken after the app has been frozen for so long that the session is going to be terminated. So let's delve deeper a little bit. Here's a great visual representation of this problem. The root cause of what caused the app freezes happens when the app originally freezes. However, if you wait to collect the stack trace until the several seconds have elapsed, you're getting a false picture. You're looking at the symptom instead of the root cause. This is why so many mobile developers get frustrated when looking at the ANR data provided by Firebase or Google Play Console. They're really trying to solve an issue with data that doesn't tell the full story. Also because the apps can freeze in many ways. The same final stack trace can stem from any number of initial conditions. So rather than focusing on symptom, let's focus on the root cause. What you need is to understand the impact and get to the root cause of ANRs. Is it the ad SDKs or the app code? In the gaming world and in other customers, what we have seen is there are a lot of ANRs which are caused by the third-party SDKs, including the ads SDKs. Or it could be caused by your own app code. Embrace, we capture stack traces at different intervals during the whole app is in foreground or in the background. And we take all that data and we correlate all the data to provide more meaningful information in terms of which helps in identifying what could be the potential causes which are causing the bad user experience and they are directly impacting the Google Play Store rating. My 2 cents on the Google Play rating, it's very important because Google cares about the user experience and the user expectation. And if your ANR percentage is above 0.4, your app rating goes down. And that impacts your overall business growth and revenue. We provide impact-based prioritization and analysis to more rapidly solve the ANRs. On the right side, if you see, there's a package which has been highlighted as an error source, which is causing 4.2% and is affecting 0.37% of the sessions. So we're fingerprinting the ANR with the Google ANR data, helping identify if issues most likely caused by some advertising SDKs or the customer app code through multiple correlations and analysis. Talking about the stack traces, as I mentioned, we capture stack traces at different intervals. Rather than focusing on the symptom, we are focusing on the root cause. What you see over here is a flame graph. Here in this flame graph, it really helps you identify combining the stack traces from the moment when the ANR started. This flame graph helps you identify which particular method is being called more and has taken more time over your expectation. And then it helps you identify the root cause of the ANR. Some key tips for solving the ANRs. Detect your freezes and ANRs as early as possible to get closer to the root cause analysis. Review the stack traces throughout an ANR for better debugging context. We cannot wait for the symptom when the ANR happens, capture the stack trace, start early on, start when the ANR starts to happen. Inspect more actionable patterns with stack trace flame graphs. Flame graph is the source which helps you with the root cause analysis for your ANRs. Taking on, example 3, client-side networking issues or the device-side networking issues. Remember that your infrastructure monitoring only cares about the performance of your servers. They cannot provide visibility into the client-side issues. There are many reasons your mobile app users can experience issues that your background monitoring will be blind to. For example, timeouts can happen if a network call takes too long to process on the user's device. In addition, connection errors will never make it to your backend. In addition, third-party SDKs are not sending the network calls to the backend. So if there are excessive calls, slow calls, failing calls, or blocking calls, you will not have that visibility. There's so many 400 errors will also rarely trigger alerts in your backend monitoring because they are viewed as the client-side errors. Failing image calls on the key product images can easily result in sizable revenue leaks. Imagine if you're a hotel company and if your user is trying to book a hotel, but if they're not able to see the images, you are going to lose that customer. What you are used to is to rely on the backend monitoring for the health of your endpoints. This is no longer enough. As mobile apps has become increasingly complex, the interaction between your code, someone else's code, your infrastructure, someone else's infrastructure, and your users' connectivity can cause all kinds of app performance issues. Let's see what type of visibility your client-side network monitoring should provide. Because you need to monitor from the client side because that reflects the actual user experience. At minimum, your mobile monitoring solution should highlight problematic endpoints. That way you have a single place to spot issues like 400s and 500s and connection errors and various slowdowns. Endpoints will frequently have many kind of errors. So it's most helpful to see which type of errors occur the most frequently. In this example, this endpoint has a 422 error occurring at an alarming rate. However, we don't know how widespread the problem is. After all, these errors could only be occurring to a handful of users. We need to dive into some user sessions to understand what's causing them and how it impacts our users. As you can see throughout this presentation, it's more important that we understand why an issue is happening and how it is impacting your users. Next, we can review the session details to see what leads up to the issue and what happens after. Are users able to continue navigating the app? Are they abandoning the app right away? Quickly answering these questions will help your mobile team better prioritize the network issues they want to tackle based on their true user and the business impact. This is the session timeline from Embrace as a product. What you see over here is there's an endpoint which is running into 422, and when you click on the impact, you land on a user session timeline which is representing there is a call which was being made to the MDN and it is resulting in 422. You can use this to replay the session in your test environments so that you can reproduce the issue. Also, it will help you program better in case if the user is in a different region, which is that information is also available on the user session so that you can program differently for that particular piece of code. So, key tips for solving the client-side networking issues. The biggest takeaway is that you need to monitor your app from the perspective of your users. Anything less and you won't understand how technical failures are resulting in user frustration and negative business outcomes. It's also important you have a way to uncover insights without requiring manual investigations, and that you can quickly inspect network calls with the context of actual user sessions. We haven't spent much time on alerts, but this level of visibility allows your team to set up alerts at custom thresholds that minimize the noise without sacrificing your ability to proactively address issues. So let's talk about the key takeaways. We're coming towards the end. I hope you found this talk helpful in providing some guidance on the type of monitoring that will help you deliver the best mobile user experience. We have talked through three common sources of app performance regressions, namely slow startup times, freezes and ANRs, and networking issues. We have gone over the importance of mobile observability solutions so that you can not only monitor the metrics that matter to your business, but also dive directly from any metric to a complete detail of the affected user session. Finally, I've also shared a few techniques for how your team can get to the root cause of a performance issues once you know there's a problem. Let's be real, issues exist, but how those issues impact your business, your users, and your overall growth can be easily correlated with Embrace. Thank you for listening. Thank you for joining.